Welcome to part 2 of notes 12.1, 2, and 4. We're going to pick up where we left off, which is talking about the volume of a cube. Now, a cube is a rectangular prism, so you can certainly use all of the formulas that we've learned for lateral area, total area, and volume as far as it applies to a cube. However, let's think back to that net that we drew. In that net, we drew 6 squares, essentially. So I find it easier to think about the cube in terms of how it relates to that net. So what I mean by that is every edge, let's call it S, right? Because it's the side of a square, so every edge is the side of a square, so we're going to call that S. Well, in a cube, all of these are S. So essentially the volume of my cube is this times this times this. So my volume equals my side cubed. All right, which means that if I have 216 as my volume, then that's equal to S cubed. So how do I figure out what S is? Well, you may or may not be familiar with it, but remember how when we had something like x squared equals 16, we would take the square root of both sides? Because a square root undoes a square. Well, there's also something that undoes a cube, and it's called a cube root. All right, so it looks something like this, has a little 3 in front of that radical symbol. So we would take the cube root of both sides. And you can do it in your calculator. So pull out your calculator right now. Now in reality, you should have your cubes memorized from way back in first semester when we gave you that cube and square series of numbers to memorize. But let's say, for some crazy reason, that you've totally forgotten how to do your cubes. Well, if you push the math button on your calculator, right, you can see down here at number 4, it's got that cube root symbol. And then we just type in our number 216, and we hit enter, and it tells us that the cube root of 216 is 6. So that is for all of you who have totally forgotten how to do your cubes. All right, so we got our edge was 6 meters. So for our total area, well, the area of one face is going to be 6 times 6. So the area of my square here is going to be 36 meters squared. And then there are 6 faces. So I'm going to take 6 times 36, and I'm going to get 216 meters squared. So that's interesting that my total area was the same as my volume. I wonder if that's true all the time. Well, look at here. We've got the opportunity to answer that question. So why don't you go ahead and answer that question, and I'm going to ask you for the answer and a little bit more about why these two are the same in the notes check. All right, moving on. We need to find the lateral area, surface area, and volume of a pentagonal prism with a height of 4 and a base edge of 5. Okay, so not so bad. Let's think about what a pentagonal prism looks like. So it's got a pentagon, and it's actually got 2 of those, and something like that, and they're all connected by these straight lines. So that one goes to that one, and that one goes to that one, and so on and so forth. Don't you wish you had a drawing tool like I do? It'd be so cool. All right, so there's my pentagonal prism. And it's got a height of 4 centimeters and a base edge of 5 centimeters. All right, super fabulous. So we need to find the lateral area, which is the perimeter times the height. We need to find the surface area, which is the perimeter times the height plus 2 times the area of the base. And then we need to find the volume, which is area of the base times the height. So we need to know what P equals, we need to know what H equals, and we need to know what B equals. All right, so P, let me see, is perimeter of the base. Each edge of the base is 5. There's 5 of those, so that is 25 centimeters. My height is the distance between the bases, so my height is 4 centimeters. And then the area of my base. And we come to a grinding halt. So how do I find the area of a pentagon with a side edge of 5 centimeters? Oh, remember our old friend area equals 1/2 AP, the way that we find the area of any regular polygon, that's what we're going to have to use here. And so we need to know what the apothem is. There's my apothem. And we already know what the perimeter is, so that's something good. Okay, so we know that a whole side is 5, so a half side is 2.5. We're looking for the apothem. And the other thing that we can know or quickly find out is what the measure of this angle is right here. Do you remember how to do that? Remember, this is inscribed in a circle, and it intersects the circle in 5 spots, so that's 360 divided by 5, and that gives me my central angle, and then, which I believe is 72. And then I take that central angle and I divide it in half, and I find the measure of this angle right here, which is 36 degrees. All right, so now in order to find my apothem, I've got my opposite. I'm looking for my adjacent. I know my angle measure, so opposite and adjacent is tangent. So the tangent of 36 degrees is going to be my opposite, 2.5, over my adjacent, which is my apothem. So my apothem is going to equal 2.5 divided by the tangent of 36. All right, so I'm going to type this into my calculator. I'm going to type in that the area of my base is going to equal 1/2 of 2.5 tan 36 times my perimeter, which we already said was 25. All right, so let's break out our calculator and type all of that in. So 0.5 times 2.5 divided by tangent of 36, close my parentheses, and I forgot to put parentheses around that, so that's okay though, times 25. And I get 43.01 blah blah blah. All right, so that is the area of my base. 43.011 centimeters squared. All right, so let's see what we got going on here. So my lateral area is going to be 25 times 4. So my lateral area is going to be 100, and that would be centimeters squared. My surface area is going to be that 100 plus 2 times the area of my base, which is that 43.011 and change. All right, so that gets me 186 point, and that's not really going to be significant, so I'm going to go ahead and just round to the nearest whole centimeter, or in this case, centimeter squared. All right, and then my volume is going to be that 43.011 times 4. And just to make sure that this doesn't necessarily wind up changing it a whole lot, I'm going to take that area that I found right there, and I'm just going to multiply it times 4 and see what happens. All right, it still doesn't change it, so I'm good there. I get 172 centimeters cubed. Okay. So this is not so bad, except for when your base is something not a rectangle or a triangle, and then it makes life a little more difficult because you have to go ahead and find the area of the base. But since you all did so well in our last unit on area, you should not have a problem with that. All right, so I would like you to do this one. We have a hexagonal prism. Hexagonal means 6 sides, and it's got a base edge of 6 and a height of 8, and I want you to find all of these pieces. So go ahead and do that and come back to check your answers. Hit pause now. All right, so if you draw a quick sketch of your hexagonal prism, looks something like this. You should have found that the perimeter of your base was 36, the height obviously was 8, and then the area of the base was 54 radical 3. Now, here's my sketch of my hexagon, and remember, the hexagon is one of those special polygons that contains a special right triangle, a 30, 60, 90 special right triangle. And remember, if it can be done with a radical, it must be done with a radical. So you should not have done this one with trig. And when we plug it into 1/2 AP, we get 54 radical 3. So that is the area of my base. And then I put that into, I put all those that I found into my equations, and I should have gotten 288 for my lateral area. And then for my surface area, I should have gotten 288 plus 180 radical 3. This is as simplified as it gets. You cannot combine these two because something with a radical cannot be added to something without a radical. So this is the answer. And then for my volume, you should have gotten 432 radical 3. How'd you do? If you have any questions, be sure you ask in class. All right. We have an equilateral triangular prism. And we have to find the lateral area, which is perimeter times height, the surface area, which is perimeter times height plus 2b, and the volume, which is big BH. So you can see if you write it down every single time, you're going to have it memorized by the time you're done working some problems. All right, so we need to know what P is, we need to know what H is, and we need to know what big B is. Well, P, each side is 6, there's 3 of them, so that's 18. By height is the distance between the bases, so it is 8. And then we have to do the area of the base. Okay, so area of the base is a triangle, so we can do base times height divided by 2 if we want to find that area. Just keep in mind that this height and this height are 2 different heights. Don't get those confused. So we need to know what the height of this triangle is right here. Well, you know, there's a couple of different ways we can find this area. But if we choose to do this as a height, then that altitude, because this is an equilateral triangle, it bisects the side, and this is a 60-degree angle, this is a 30-degree angle, so we've got a 30, 60, 90 right triangle, which means that this height is 3 radical 3 when we fill in our pattern. So we have 3 radical 3 times 6 divided by 2. So the area of our base is basically 9 radical 3 inches squared. All right, so now we have all our pieces. Let's go ahead and fill them in. So 18 times 8 gives me 144, and units are inches squared. We take that 144 and we add 2 times the area of my base, which is 9 radical 3, which means we get 144 plus 18 radical 3 inches squared for our surface area. And then my volume is the 9 radical 3 times my height, which is 8. So I get 72 radical 3 inches cubed. Not so bad. Just make sure you have all of these formulas memorized and know what each of the pieces mean, and you will be in good shape. This concludes our notes for today. Be sure you go on and do the notes check. And if you have any questions, be sure to ask about them in class. Thanks.